Hi, and welcome to the Bare Basics lesson on graphing linear equations. Let's begin by a quick revision of what a linear equation actually is. A linear relationship or equation is one that can be plotted as a straight line. The clue is in the word linear, which actually features the word line. The highest degree of any variable in the equation is 1, so you'll never see an x squared or an x cubed. If anything, you'll see an x. And the general equation of the line is y equals mx plus c. When we plot or graph the linear equation, it can be graphed on the Cartesian plane. The first step is to work out the ordered pairs that form the path of the equation. To do this, we can create a table of values. For example, for the equation y equals 2x minus 1, we can set up a table of values with our x value across the top, and we can pick any of those, and then we substitute that into our equation to get our y value. For example, when x is negative 2, 2 times negative 2 is negative 4, minus 1 gives us the negative 5 that you see in the y cell directly below the negative 2 for x. When x equals 1, 2 times 1 is 2, minus 1 is 1, and there is our value. Now, these values give us our sets of ordered pairs that we can then plot, our x value and our y value, and then we can draw a line, and there it is. Now, when you are actually plotting these and you need to work out your table, I strongly suggest that you plot at least 3 points. If you plot 2 points only and one of them is incorrect, your whole line is incorrect. But if you plot at least 3 and they're not falling in a straight line, you know then that that's your clue to go back and rework the maths to see which of the points is incorrect. The equation of a straight line y equals mx plus c has meaning. The x and the y values are the points, the coordinates, and for a point to be on that line, you must be able to substitute in x and end up with the y value that you know. The m is the gradient or rate of change. So depending on what type of problem you've been given, particularly in a word problem, it's the growing part of the equation. It might also use the word rate. People are paid at a rate, or a taxi charges at a rate of. The c value is the y-intercept, or the constant. So in the taxi scenario, it would be the flagpole. It's the same no matter how far you travel in the taxi. Parallel lines are the same distance apart no matter how far each line goes. The thing you need to know about parallel lines is that they will have the same gradient. So here's an example for you. We have y equals 2x plus 3. And if we were just to slide that down the graph, you can see that we've then got y equals 2x plus 1. The only difference between these lines is where they actually cross over the y-axis. So the gradients are the same, therefore they must be parallel. Opposite to that is perpendicular lines. Perpendicular lines intersect at a 90-degree angle. The gradients must multiply together to get negative 1. And once again, let's look at an example. I have 2 lines here. The first is y is equal to negative a third x plus 2, and the second is y equals 3x minus 4. If you multiply negative a third and 3 together, you will get negative 1 because the 3's cancel. If you have any questions, just ask me in class or email me. This has been your Bare Basics lesson on plotting equations and points on a Cartesian plane. Remember, the idea of Bare Basics is to make maths more bearable.